Okay then, so in today's class we're going to start with the haloalkane and haloarene chapter. So we already covered all these things like importance and all these points. That how about the importance here? Observe this here that DDT part we already covered. That DDT is a very much important point. What is DDT? DDT is a diphenyl. Like if you to observe, there is a two chlorine here and then two phenyl here and then trichloroethene. This is the name. This part we already covered thyroxine and all this thing. These slide only for the not. Maybe you're not able to join the previous class. Okay. So that's then we are discussing about the biological importance and the last topic which we covered there is the Lucas reagent. Okay, so that this part we already covered. Lucas reagent. What is the Lucas reagent? This is going to be the HCl. It's okay. So this is a HCl simply that if you are having HCl and the presence ZnCl2 there, we have to follow the SN2 mechanism. You can say here that is the formation of carbocation. I'm sorry, SN1 mechanism. It means formation of carbocation take place. Okay, so this part we already covered. If you are having a tertiary alcohol is there, there is an instant turbidity. Once you have to add the Lucas reagent into the solution, instant turbidity. For the secondary one, it will take 5 to 10 minutes, and for the primary one, it there is a no turbidity appear. So this topic we already covered in the previous class, and this slide basically we already cover that observe this point here. This one that this is OR KBR and there we discuss about how the mechanism is going to take place whenever every time you are having OH there's a H positive connected here and then leave the molecule and this is how the reaction is going on. Now the new topic starting from this slide only. Okay, so this is the topic of discussion right now. Okay, now my question to you everyone, can you just tell me that is it possible for a benzene to undergo a direct reaction if we are having a phenol? Let me just add a slide here. Yes, please, anyone answer this question? Maybe you're not getting. Listen, if you are having a benzene, okay, if this benzene is connected with some OH group, so my question to you, like if you to observe normal, if there is a OH group in the previous class we discussed about, if you are having some H positive and you to add some halogen there, let's say, okay, so what is happening? This is directly connected with the chlorine part there. But my question to you that here is it directly possible if you are having a OH group and it's going to react with the part here? What do you think about this? Yes or no? No. Difficult. No. Right. So, anyone doing the reason behind this? Why there is a no? So what? That if we are having a resonance, then what is going to happen there? Yes, please. Okay, so listen what is happening there. This is a normally sp3 hybridized carbon, but if you to observe here, here we are having a lone pair, and everyone you know, it is a basically a plus M group, right? It's a plus M group. So the lone pair start moving inside the ring like this, and just because of this, actually how the bond look like that this is a benzene and there is a partial double bond character is there. It means due to the resonance, it achieves some sp2 hybridization kind of thing and difficult to break. That's why it's difficult in benzene, okay, to directly undergo this kind of reaction there. Okay, be noted this point. Okay, so means this is already written here. If you to observe the slide here, what is written here? Aryl halide prepared from the phenol is not easy for you. Okay, so what is the key point here? That the reason is what? Partial double bond, which is difficult to break. Okay, it means we are having different method here. Of course, we are having a different method if you want to form a aryl halide directly. Okay, so this is just a topic of discussion. Now let's continue further. That if observe this point here. Let's move further. Look at this point. Then the next method of preparation. In the previous class, we started with the method of preparation, and the first method of preparation we started there that from alcohol. And from the alcohol part, the first one we already covered that from Lucas reagent and from acid as well. Now the second method is going to be the phosphorus halide. Okay. For this portion, you have to recall that which chapter P block element. Okay, quickly recall the P block element is there. So let me just move again. Okay. So what we're discussing here, that is the PCl3 is there. If you're having a PCl3, okay, can you just tell me what is happening there? And if you're having a PCl5, then what is happening there? Do you know the reason behind this? Quickly recall the P block element. If you're having PCl3, if you undergo hydrolysis part there, then what we are getting? Very good evening, Yash. And please, it's a request to everyone from the next class, be on a time because it's already 11 minute. Okay, please do this. So let's just back here. If you are having a PCl3 there, I hope everyone you already know that if you are having a PCl3 there, there is a direct addition. Means whatever be the R you are having RH, let's say, there is a formation of RX take place. But on the other hand, if you are having a PCl5, so PCl5 is basically not going to participate like this. So what is the new here? Let's just back here. If you're observing, this is my PX3. PX3 can be PCl3 there. PX3 can be PBr3 there. Okay, it can't be PF3 because PF3 is not going to react, and one more PI3 is not really that much stable there. So only that is PCl3 and PBr3 is going to participate here. That if you were to add, this is a RX plus H3PO3 generated. With PX3, that it's a phosphorus acid. Okay, this is a part of the p block element, and this is Rx, some halide generated. And next, that is red phosphorus, and this is X2. This is nothing, that is a phosphorus in the presence of X2 there. And then bromine or iodine. So every time if you have to note it, fluorine is not going to participate because of fluorine because for the fluorine case we are having a different other cases as well. So again, this is Rx and this is a PCl5. If you are having a PCl5, we are getting POCl3 plus HCl generated there. Okay, this is a new point here. This slide is just only for understanding. Mechanism is important. No, in this case, we are not going to start with the mechanism part. Only the importance is this slide only. Next topic, next one, that, ma'am, like how to directly do the reaction. There is any kind of trick? Yes, there is a trick. If you are having alcohol, there is a PCl3 and there is a RCl, how to form there? So you have to do what? That is, you have to write P, okay? And this, observe this chlorine above, chlorine above, chlorine above. Every R just connected with the chlorine, chlorine, chlorine. And whatever be the O part here, this is connected with the phosphorus. So it's become H3PO3 and RCl generated. Same you can go with the PCl5 there. That again you have to write the RH and this portion is go with this and this portion is go with this and we are just left with this portion only, that is POCl3, HCl and this. Okay, because in organic chemistry, every time we don't know the mechanism, so these kind of trick is really important for you. Okay, so I hope you are able to understand this point here. Okay. Yes, any problem till now? Okay, actually, see, there's just so many like tab is there. Okay, if maybe I miss your doubt, please ask if you're having any doubt. Okay, feel free to open your mic as well. This is all for the trick. Next method is going to be the reaction of the alcohol with
मैम
SOCl2. Yes, please.
मैम ऑर्गेनिक केमिस्ट्री स्टार्ट हो गई क्या?
Yes, Payal. It's not start actually. I'm only covering the organic topic because we already covered the physical and inorganic classes in a regular session as well, right?
ओके मैम,
Only
थैंक
organic
यू
is
मैम.
going on. Okay, you're welcome. So let's just back here. What we're observing here, that is the next one is the SOCl2 there. So put 2 to 3 start, it's going to be very much important reaction. Do you know in a laboratory, if you want to make a halide, alkyl halide, so this is the most commonly used reaction there. Okay. So my question to you, what do you think about this? Like why this is a very famous reaction? Let me just do what? It's a gaseous form. It's a gaseous form. Think about it that why the alcohol when reacted with the SOCl2 there, it's a one of the famous reaction in the laboratory. Anyone do the reason behind this? Answer. Yes, very good. Okay, because here we are having a gaseous byproduct. Gaseous byproduct play a very much important role here. You know, in organic chemistry, what is the problem? Because it's very difficult for us to just that remove the thing if we are having a side product. So what is the important point here? That if you have to note it here, the gaseous product will be very much helpful for you. Okay, so this is the simple easy point here. Okay, I hope this point is clear for everyone. And like the other cases, here we are having a trick as well. So let's just back here. How about the trick? Same alcohol, SO. One part is go with this portion, one part is go with this, and we are enter with this here. Okay, so important is what? That why this is important reaction, why this is a famous reaction? Because here there is a formation of, I'm sorry. Okay, so this is combined here and this is combined here. Let's continue further. Now, this the reason which I just explained to you already written here, that this reaction is the very good reaction there, good method. Why? Because the byproduct of the gaseous reaction in nature especially escape out, and that's why. And one more thing, it's follow the SN1 mechanism. Okay, in SN1 mechanism, there is a retention of configuration take place. Now, maybe the next question, ma'am, what is the meaning of this word retention of configuration take place, right? So let's just try to understand this point as well, that what is the meaning of this word retention of configuration. Okay, for example, if let's suppose this is some carbon is there. Okay, anyway, I guess it's visible. Okay then. So let's continue what we are what I'm explaining to you, retention of configuration. For example, this is my R. Okay, let's see some CS3 group connected here. Let's see some hydrogen is connected here. Okay, and let's see this is my chlorine. Chlorine is a living group. Okay, this is connected here, and let's see some. Okay, one more CH2 and CH3 group is connected here. Okay, let's suppose this is my nucleophile. It's a nucleophile. When nucleophile attack here, so what is happening there? There is a two possibility. Maybe that is the nucleophile connected like this. Okay, condition number one, everything will remain same. Or maybe the nucleophile connected like this. Okay, like this. So what you're observing, if you're to noted here, it's a wedge position, and it's this is also the wedge. So what is it? It's a retention of configuration. It's a retention of configuration. But on the other hand, if you have to note it from this point here, observe this, notice this, that from there to there it's a inversion, because wedge become dash here, so it's a inversion there. So there's a two kind of configuration or a kind of product we are getting. One is retention, follow the retention means as it is, or the inversion there. What is SN1 versus what is SN2? After the completion of the preparation part, we will start with that part as well. Okay, for this point only, be noted that what is the meaning of this word retention and all this thing. Observe this slide here, that if you to observe, look at this, that okay, the reaction, listen, the reaction of the alcohol with the thionyl chloride in the presence of pyridine, it's very really very much important point here. We are using pyridine as a solvent. Okay, we are using pyridine as a solvent. Yes, there is a reason as well why we are using pyridine as a solvent, so that is it causes the inversion of configuration through SN2 mechanism. Okay, we are not getting, ma'am. Listen, if you have to back here, what is written here? In this reaction, we have to follow the SN1 mechanism. Okay, it means in retention of configuration take place. But on the other hand, if in the same reaction you are using pyridine as a solvent there, the same reaction follow the SN2 mechanism, and now there is a formation of the this kind of product take place. It's an inversion of configuration. Okay, maybe you're not getting what is the meaning of inversion of configuration. If you want to observe this, maybe you know the S or R nomenclature, yes or no, you know or not? S and R nomenclature, do you know? Yes, everyone you know or not? Little bit. Okay then, for this class only, because of course this is a part of the stereochemistry. Okay, so let's just give the priority. Priority wise, the atom which one has a maximum atomic number got the first priority. Okay, so this one. Okay, because oxygen 8 is the atomic number, and then next is going to be the this carbon, 2 carbon, and then 3. So if you have to follow this, that how about the rotation is there? This is this like this. What is it? Clockwise or anti-clockwise? You know the clockwise or anti-clockwise? Anti-clockwise, right? So which what we are at up here? That is S. S means anti-clockwise. Okay. And on the other hand, in this case, that this is 1, 2, and 3. Okay, 1, 2, and 3. If you have to rotate again, then how about the configuration? Which kind of configuration we are getting? What is it? It clockwise or anti-clockwise? It's a clockwise. Okay, clockwise means are there? Yes, but no. First of all, you have to check it for clockwise or anti-clockwise. Now, next is going to be the wedge position. First of all, this is the rule as it is. Now, the second important point is there. If the fourth group present at wedge position, S become R, or R become S. Means, first of all, you to simply identify the configuration. Is it S or R, like clockwise or anti-clockwise? Then you to revert the plane. Okay. If it means the fourth group at the wedge position, okay, let's just wait. Okay, I have to explain in very detail. Maybe you're not able to understand. Okay. Okay. So listen, what is the meaning of this RNS? Okay, before starting with this, we are clear about one point, chiral carbon. So what now the first question for you, that is, what is chiral carbon? So chiral carbon, you can say the atom which is connected with the four different group. So you can say atom connected, atom connected with four different group. So if you are having a different group, so that is going to be the chiral carbon. For example, how about the chiral carbon? If this is my carbon, this is connected with, let's say, OH, okay, CH3, let's say, and the COH is there, or let's say hydrogen. So for different group, is this chiral? Yes, this is chiral. Now the next rule said that you to give the priority. Priority means the number there. So how about the numbering? The numbering, or the priority group said that which one has a maximum atomic number got the first priority. You can say it's going to be the one, okay, then carbon 2, and then 3 carbon is there. Then you'll be like, ma'am, this is also carbon, this is also carbon. Then if there is a tie for the first atom, then you have to go with the second one. This is my carbon, so with respect to carbon, this is hydrogen, but here with respect to carbon, this is oxygen. So yes, if there is a tie for the carbon, then check it for the next atom. This is my hydrogen means 1, and this is oxygen means 8. So that's why this huge have the second priority. It's a fourth priority group. And if you to rotate the molecule, so it's become 1, okay, it's 1, 2, and 3, like this. Okay, so which kind of direction this is? Anti-clockwise, you can say. If it is anti-clockwise, it's going to be the S configuration. But again, the next point is what? If fourth priority group present at wedge position, so S convert into the R. If fourth priority group present at a wedge position, so S will remain S. This is important. Wedge position, no change. Dash position, yes, it will be change here. Okay, so this is a simple rule that how to check it for the chirality point here. So let this back here. Now observe this. This is S. Technically this is S, but now it's going to convert into the R point here. Okay, so it's become R, and it's become S. Anyway, what I want to explain to you, R become S. It's an inversion of configuration take place. Okay, so this is a simple meaning. The reaction of SOCl2 follow the SN1 mechanism. Okay, there is a retention of configuration, but if you to use the pyridine, the inversion of configuration take place, and the reaction follow the SN2 mechanism. Okay, so this is all for the point. I hope it's clear, but still not clear. Now your turn. Please ask. Okay, back here, please. Yes, is this point clear for everyone? Okay, then. So that's it. This is all for the case. Okay. Okay, so that's it. This is all for the SOCl2 part there. Now let's move for the second method. Okay, so right now we are just covering only the first method, that preparation of the alkyl halide from alcohol. Now the second method is going to be the from hydrocarbon. And from hydrocarbon point, the important is what? From alkane part here, from alkanes. So from alkane, this is written, normally read this. Preparation of alkyl halide from alkane follow the free radical mechanism. Free radical mechanism, every time we have to follow. Quickly recall the 11th class reaction, that if you are having a CH4 and if you to use the Cl2 in the presence of light, there is a CC, C4X is there, 3 can be there, okay, or 2x2 can be there, or CX3 can be there. It means mono, as compared to the one halogen, there is a so many halogen take place. Simple sorted, it's a radical mechanism. We have to follow the radical mechanism, and once the radical form in a reaction, yes, there is a formation of radical take place, and so many product we are end up. So look at this, there is a formation of mono or poly there. How about the case, ma'am? Look at this. If this is my alkyl halide, you have to add the Cl2 in the presence of light. What we are getting in this case, that, observe this, maybe the chlorine connected at the one position. Look at this, 1, 2, and 3. or maybe the chlorine connected with the 1, 2 and 2 second position there. So we are getting two kind of product. Now the question be like, one is major or the second is major, like primary is major or secondary is major. Now it's very much important point. Every time in a books it is written like it's a 98% product, it's a 2% product, or it's a 3% product. Do you know like how to identify the percentage yield for a product? Okay. Now the next formula is this, like how to identify the yield of a particular product. Okay, so let's move here that how to solve this point here. So first of all, in today's class or in your topic only, the topic of discussion, the product distribution in chlorination and bromination. Okay, first of all, let's start with the chlorination, then followed by bromination. So how about the chlorination here? That if you to follow the chlorination, obviously we are having a choice. It can be connected at any position. Look at this. It's a 1, 2, 3, and 4. It may be connected at one position or two position. Don't say, ma'am, why not 4 and 3? Okay. So listen, if let's suppose the chlorine connected here, so obviously you have to count the number be like 1, 2. So every time that is a symmetry. Maybe you can start from this side or this side, it will remain same. Okay. So only two feasible position for the connection of the chlorine here, one or two. So if you have to observe this point here, it's a 28% and it's a 72%. But the question like why this is 28% and why this is 72%? Yes, it's an important question. It's already asked so many times in a JEE exam that for the chlorination, the primary is 1, secondary is 3.8, and tertiary is 5. Ma'am, so do we have to remember the ratio? Yes. The ratio directly asked so many times. The ratio for the chlorination is 3, 1 ratio, 3.8 ratio, 5.0 ratio there. It's really very much important ratio. It means this ratio simply represent if you are moving from primary alkane to secondary alkane to tertiary alkane, the rate of the reaction start increasing, or you can say the rate of formation of free radicals start increasing there. Why? Because we know tertiary carbocation is free radical is more stable, or the secondary is more stable, or the primary. We know this thing. But okay, everything is sorted. But how to apply the formula? Like how to get all this thing? This is a 78%, 28% is yield or a 72% yield. It's also important, right? So let's see how to identify this. It's a numerical based question. Okay, yes, already asked so many times. So be noted, important question. How to find? So let's see. First of all, there is a formula for you. This is a formula. Okay, this is normally experimental yield. So do we have to remember the ratio? Yes, ratio is also very much important here. Okay, ratio part is also important. Okay then. So what is the formula? Everyone noted this formula. It's very much important formula. What is the formula? Relative yield is equal to the number of hydrogen atom into reactivity. Now, first of all, we have to go with the primary carbon, because in this case, there's a two kind of carbon only. Primary carbon, this is primary carbon, secondary carbon, primary carbon. In the previous class, we already covered what is primary carbon, what is secondary carbon, or what is primary carbon. Okay, so formula said number of hydrogen there. Can you just tell me how many primary carbon? How many primary carbon in this formula? Okay, without any cheating, I know everything is written on a slide, but still, how many primary carbon? Sorry, hydrogen, I'm sorry. Two, two, two. I'm repeating my question again. How many primary hydrogen? Six, right? And come on, it's already marked. There's a total six hydrogens there, right? So observe this six hydrogen. So I can write that is I'm having six hydrogen. And what about the reactivity there? The ratio said one ratio. Back how to apply the formula. One ratio, 3.8 ratio, and 5.0 ratio. So it means it's a secondary, primary or secondary. It's a primary there. So you have to multiply six with the one. How much we are end up? Six is the correct answer here. Now let's start with the secondary point here. How about the secondary? So again, there's a only two secondary carbon. This and this carbon is the secondary. It's a secondary and it's a secondary. How many secondary hydrogen is there? Total four. So you can say 4 multiply. What about the ratio? 3.8 there. How much we are getting? 15.2. Okay. Now there's a question for you, that if you to note it here, that for the primary one, for the primary we are getting 6 value, and for the secondary we are getting 15 value, right? 15 point, no, 15.2. Okay, 15.2 I have to write here. For the secondary 15.2. Can you just tell me the percentage of the primary? Because you are a mathematics student, I hope you already know how to find the percentage of primary and how to find out the percentage of the secondary. Yes, please. This is a question for you. How much you're getting? 2%. Primary 6, secondary is 15.5. How to find the percentage? You are having two subject, right? Yeah, Jay, you're right. Okay, means approximates 77.23 there, right? So approximate this you are getting. So let's see how to do this. That percentage, this is 6. If you have to add 6 plus 15.2, how much we are end up? That is a 21.2. Multiply with 100, right? Similarly, you can go with this. That is, it's a secondary one. 15.2 divided by 21.2 and multiply with 100. Okay, we need to solve this. How much we are going to get there? Okay, that observe this, this is already 12, 21.2 there, and if you have to observe the ratio here, look at this. Okay, it's 28% and it's a 72% here. And wait, but let's back to the previous slide. If you have to observe this ratio here, we already covered 28 and 72%. Okay, and this is how the ratio for the given reaction is every time given you in the book and every point there. Okay, same you can go with the bromination. How about the bromination there? For the bromination, this is all for the chlorination. For the bromination, this is the point here. Same question for you. Okay, for this question, we'll be having 3 minute total. Okay, now you have to answer the same question. If you're having same butane, secondary and primary, this is the ratio. And again, it's important. For the bromination, it's 1600 ratio, 80 ratio 1. Tertiary, secondary, and primary. So according to you, same question, you have to follow with the bromination and let me know the ratio of the bromination primary and secondary. Your time start now, 2 minutes. Same formula you have to apply. That is the number of hydrogen multiply with the reactivity there. Okay, please answer this question. Of course, Trishanji, just wait. Okay. Jay, you already know the answer because you're very fast. Okay, this is the formula. The yellow one is the formula there. That number of hydrogen multiply with reactivity. Okay, hydrogen you have to count and the reactivity you have to go with the ratio part here. Okay, this is all for the reactivity. किसका क्या दिक्कत हो रही है? मैं फोड़ दूंगी किस कौन है यो? Okay, Payal, I will explain. Don't worry about this if you are not getting. Okay, of course you have to remember. Okay, it's really very much important. Okay, it's important. That's why I told you it's very much important here. Okay. If slide is not visible, please let me know. Okay, so that I can shift my video. Okay, let's just put here. Now the slide is clearly visible, right? So this is all for the bromination here. That I will explain. Don't worry. Okay, so let's see how to that find the answer for this question. Okay, there. So let's start again. That again you are having carbon, 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 carbon. So primary hydrogen, first of all, we are calculating. Okay. So primary means terminal carbon only. It's a primary part here. Okay. Primary there. So how about the hydrogen 1, 2, and 3, and 4, and 5, and 6, total 6. Okay, for the bromination, we just start. That is tertiary ratio, secondary ratio, primary. What about the ratio there? It's become 1600 ratio, 80 ratio, 1. Right? So you can say 6 and secondary, so multiply with 80. Total, how much we are getting? That is, it's become 4. Wait, I'm sorry, it's primary, right? Primary, so it's become 1. So you can say it's 1. So how much we're getting? 6 there. Similarly, you can go with the secondary. That how about the secondary? 1 hydrogen, 2 hydrogen, 3 hydrogen, and 4 hydrogen. So 1, 2, 3, and 4 total. Okay. So 4 multiply with secondary means 80. So 84 is it's become 320 there. Then total become 323. 26 there. Okay, so let's just back here, then we have to find the reactivity, like 6 divided by 326, and then 320 divided by 326 multiplied with 100. This is the percentage we are getting. Okay, is this point clear? Was asking, please, Priya, I guess, right, Priya? I hope this point is clear for you. Okay, of course, Diksha, I will. Don't worry about this, I will send all the slide to you. Okay, no need to. Okay, where's the slide? Okay, let me just remove the thing so that you are able to note it down. Okay, this is the first slide for the bromination. This is the second slide for the bromination. Okay, are you done now? Previous. This one in the group. You are not in a group. Can anyone please tell him or her? Okay, in the group, please. See, Diksha, reactivity is just an experimental point. Okay, this is just experimental value. Okay, you have to remember for the bromination and chlorination. Okay, simple. Okay, so every time it's mentioned. Okay, and in the paper you have to know. Like that's why I told you for the chlorination, it have to be that 3.5 for the secondary, and for the primary it's going to be the one. And for this one, that is 1680 and one is there. Okay, then that's it. So let's just back here. This is all for the bromination point here. I hope this point is clear for everyone. Yes, this is a numerical based question. Maybe it will ask. Okay. Now next question to you. Now a very much important point for you, that now you're in organic, of course. Now we are going to deal with the organic chemistry. So the important point right now is what? Okay. That reactivity and selectivity. Do you know the meaning of this word reactivity and selectivity? Okay. Just okay, whatever you know, that this is my selectivity. Okay, you know the word of meaning of this word selectivity, when you to select something, and reactive means that when something is reactive. Okay, now a general question for you, according to you. Okay, listen. Okay, just for a while, listen my point. Please discuss all this thing later. Okay, listen my point. That selectivity and reactivity. According to you, a fast reaction is reactive or a slow reaction is reactive? Think about it. A fast reaction is reactive or a slow reaction is reactive? Fast, right? Fast. Okay. Now next point to you is the fast reaction is actually selective. Think about it. If you're very fast, okay. So obviously the fast person is not that much selective. Only the slow person is selective, right? Simple, sorted answer. Right. So if you to observe here that if you're comparing the chlorine and bromine, even let me just write the reactivity order here. Okay, so reactivity wise, fluorine is very reactive. You know, so many times discussed it's a very highly explosive in nature and all these things. Fluorine is more reactive, then chlorine is more reactive, and then bromine is more reactive, and then iodine is more reactive. It means chlorine reactive, then bromine reactive. Yes, we discussed that okay, secondary is the stable because we cover that tertiary react first because that's stable carbocation, and then secondary and then primary. But question is what, that chlorine is more reactive, bromine is less reactive. But why there is a variation of the product here? If you have to observe, if you have to compare the point here, here the primary and secondary, primary is 28% and a secondary is 72%. But on the other hand, this is the primary and secondary, so it's a 2% only, it's a 98% only. Okay, so can you just tell me, okay, reactivity wise, chlorine is reactive, but who is more selective here? You know the meaning of selectivity, that when you to select something, so, yes, in both the cases, secondary is the more stable. But chlorine and bromine, which one is more selective? Bromine. Okay, that's why see this secondary is what, 98%. Yes, this question already asked in the previous year, that acceleration kind of thing. Bromine is selective or chlorine is selective. So bromine is selective and chlorine is reactive. Okay, so make a note for this one. It's important here that you can say chlorine is reactive, but bromine is selective. So let me just write. That if we are talking about the reactivity and selectivity, so this is very simple.
Excuse me, ma'am.
Yes, please.
Ma'am, can you move your video on the corner?
Oh, oh, Marcus. Okay, so chlorine is reactive and bromine is selective. Okay, it's important. That's it. This is all for the theory part. Okay, now let's solve some question only. Okay, yes, first of all, it's a request to everyone. Any problem with the theory, please ask. Okay, so in today's class, we wrap up total three topic hardly. Okay, first of all, the preparation from alcohol. Important is what SOCl2 part here. SOCl2 fluorescent mechanism and very effective method because the gaseous product is there. Okay, and then pyridine if you have to use SN2 we have to follow the next method, that this chlorination bromination. Okay, hardly two topic, not that much concept is there. Okay, now let's solve some questions only. Okay, last one, the question part only. So, okay, let's solve a question. Question number one for you. Answer this question. Question asks, which of the following halide is isobutyl bromide? I'm going to end the session and which one is the iso? Okay, because some problem, some student may be having a problem with the COD as well. Like C is the correct or D is the correct. Or what is the meaning of iso, neo, or N? No, first of all, you to answer, then I will tell you is it correct or not. D, okay. So it means D is the correct answer. Okay. Now let me tell you a very much important point. Okay, basically everyone is right. Yes, D is the correct answer here. But question be like how to identify the ISO point here. Okay. So now I will tell you kind of trick. It will work everywhere. You have to search for this one. Why? If this kind of you can say a kind of configuration there, it's become ISO. It's a Y. But on the other hand, if there is a tree formation take place, it's become neo. Okay, it's a ISO, it's a neo. Now, how about the tree and all this thing? For example, there's a question for you. If let's suppose this is my CH3, CH2, CH2, CH3, and hydrogen and CH3. So is this given thing is iso or neo? Neo, neo, neo. Hmm. Neo? Okay then. Then can you just tell me why this is a neo there? Okay. What is it? Is it hydrogen? No. Okay, that's why I write like hydrogen be like this. Wait, it's hydrogen. It's not going to count. What is the real point here? That CS3, if you to basically observe, it's nothing. It's a Y there. It means terminal have to be connected with two methyl group. Remember the definition. What is ISO? That when the terminal one is connected with the last two carbon only. So what is it now? It's a ISO actually. Okay, it's not like hydrogen is there. Oh, okay, it's become okay. Yeah, you can say, but like every time, not make false statement because sometime maybe hydrogen can be there. Okay, because see, what if? Oh, yeah, you can say. Next, please. One more question for you, Natasha. Okay, yes, I know that's why I give the question like this. Okay, so let's solve one more. Okay. Wait, I have to raise this. Yes. Is this ISO new or what? Little bit. Natasha, it's familiar. You're from the English batch or Hindi batch? I guess there's some Natasha in Hindi batch. Hmm. Okay, so let me tell you the definition. It's not like ma'am give you a trick and then apply everywhere, okay? Yes, Payal, actually see, do you know like someone told me about this like from Monday everything is going to be normal, okay? So let's wait for tomorrow only. Okay, from Monday the thing is not like on their place, so then we will continue. Okay, otherwise, of course, I have to drop out. Yes, please. Is it Neo ISO or what? Are you sure about this? This is ISO? Okay. Second last carbon connected with methyl. Okay, this is the definition. It's not like okay, find the y and it's become no, it's not like that. Okay, let me just back to the slide here. Let's see. Okay, if you to count that last second carbon. So this is my one first carbon and this is my second carbon. Is the last second carbon has two methyl? Real definition of iso is what? That is last second carbon connected with CH3 group. This is the real meaning of iso. Okay then, let's continue from this point 1 and 2. Is this last second one is connected with the methyl? No. Okay. If you to observe this last second, this is a methyl group. So my dear, it's not iso, it's not neo, it's not anything. Okay, it's not iso. Iso means be noted terminal CH3 group have to be there, terminal CH3 group have to be there. Okay, let's just back here and now try to answer this question, that basically if you have to go with this iso neo, so isn't it ma'am methyl group is connected? Okay, one methyl group is there, it's only n part here. How about this? It's also the n here. And how about this? It's a neo one. Why neo? Because terminal carbon connected with 3 methyl group. And see this terminal carbon connected with 2 CH3. CH3 is the key point here. It's not like every group. No, only CH3 have to be connected there. Okay, I hope the actual meaning of neo and iso is clear for everyone. Okay, please let me know is it clear or not. Okay, okay then let's solve one more question. Last question of the class. Okay, answer this question. Among following alcohol, the one which would react faster with the constructed HCl and anhydrous HCl2. Okay. So first of all, what is it? It's a Lucas reagent based question. Okay. So you have to identify the answer for this question. Lucas reaction. Lucas reagent. Pile. You're not in the previous class, right? Maybe you're new here. So what is the reaction there? Remember that it's follow the SNO mechanism. There is a formation of tertiary carbocation. So then C C C. Okay. Hmm. Okay, so basically you are right. Status C is going to be the correct answer. So first of all, one butanol, one carbon, two carbon, three carbon, four carbon. It's a primary alcohol. No, it's not going to react. Okay, because we know with the Lucas reagent, let's quickly recall that with this reagent, that how about the rate? Tertiary react faster than secondary and then primary. No, it's not correct here. How about the second point here? If you to observe two butanol, it means it's going to be the secondary, right? It's a secondary alcohol. But question ask about like which one react faster. Faster is the key point here. So let's see this one 2-methyl propane 2 all there. So one carbon, two carbon, three carbon. Uh, okay, second position we are having a CH3 group and here you are having a OH group. Sorry, OH group. So this is the meaning here. So if you have to know, observe, this is a tertiary. Like I hope you already know how to identify the tertiary. This carbon connected with one carbon this side, two carbon this side, and three carbon this side total. Three carbon total, right? So it's a tertiary alcohol, and hence this is going to be the correct answer to this question. And option number D, let's just check this one as well. Why not this is a correct here? So it's a propanol. So one carbon, two carbon, three carbon. What is the point of for this? Like if you to connect the methyl here, because Because if you to observe here, that because we already have this is a primary, it's nothing, it's primary alcohol there. So it's incorrect, incorrect. Only the option number C is the correct answer here, okay? Okay, done from my side. This is all for the class. If you are having any problem left, please ask. Okay, let's go slow, not very fast. Of course, Aris, first of all, I have to upload the recording and then send you the link as well. Okay. And not what is the name of the student? Sri Kumaran. I don't know the name. Someone asked me about a doubt. Okay. No, it's already started, but you know I'm a zero subscribers, so that's why. Oh, I'm sorry. Yes, Sri Kumaran. Are you there, Sri Kumaran? Maybe not, right? So if you're having problem, please ask. Okay, stand on the group and I will resolve your okay link. क्या फर्क पड़ता अब चलिए दे वैसे भी कुछ नहीं होने वाला so let's continue okay चलिए हम bye bye everyone thank you so much everyone for joining the class of course because it actually it require 50 subscriber so that's why I'm not able to do that okay so not an issue I will conduct from here only okay thank you so much then everyone for joining the class thank you so much everyone okay let's end the class. Okay, let's meet in the next class. And yes, tomorrow there's a no class because Sunday. Okay, and let's see. Probably from Monday everything is going to be normal. Okay. Thank you then. Okay. Bye bye everyone.